Alright, this is Unit Exam 5 review. Let's start with the first one, which is area of a rectangle. So area of a rectangle is length times width. And they give me the length and they give me the width. So I can multiply those two by each other. So I will have this rational expression times the other, length, and then this one's width. Okay, just like in class, the coefficients, I can set them aside and multiply them together and divide them together. And here I would get 2 times 3 divided by 8, which is 6 over 8, which is 3/4. Excuse me. Alright, so from here, now I take the radicals, that and that. Because every multiplied and divided together, I can move them into the same radical. So all that becomes 14 times 2 over 7 times 3. That's still the pink part. Here I can already simplify, but so not to confuse you, I'm going to multiply it first. So I would have 28 over 21. Okay, still the pink part. These two can be simplified by 7, so I would have 4 over 3. Okay? Now once I get there, I can't simplify it any longer. The 4 and the 3 don't simplify, so I'm pretty much done. So now I can split them back to their own square root, because I am done here. So right now I have 3/4 that was waiting for me. And then square root of 4 over square root of 3. Okay? When I split them apart, I notice that this is a perfect square, right? We know square root of 4 is 2. If you can't picture that, you can do the factors, like we did the prime factorization. 4 would be that, so 2 in, 1 out, and there's nothing left over in the radicals, it's just 2. So on the top now we have 3 times 2, because the square root of 4 became the 2. And on the bottom, I still have 4 square roots of 3. So this will become 6 over 4 square roots of 3. I will be done here, except for the fact that the denominator is an irrational number. The square root of 3, it's a square root of a non-perfect square. So this is what's making the whole denominator, the 4 square roots of 3, irrational. So I gotta get rid of that. Just like we did in class with the patterns, I need to multiply both numerator and denominator by something to get rid of that. And if you remember back from class, right, we would multiply by the square root of 3. Why did we do that? Because if I have 2 3's now inside a radical, I get 1 out. So if I already had 1, and I add another 1 inside the radical, now I can have a 3 out. Okay? And then on the top, I just multiply across, so 6 square roots of 3. Okay? And then that would be my answer. Okay? Now here, there's one more thing. Okay? So that's that. And then your 4, which was your constant, you're going to add it over here. Forgot about it. And then you would multiply. So 6 square roots of 3 over 12. Okay? Now there's one more thing to simplify here. I know that's a lot of steps, but we have a fraction. We know how to simplify fractions, 6 and 12. Right? So we have square root of 3 over 2. You can also leave the 1 here. Okay, and then that now is our final answer. So we had several steps in this one. First, we did the coefficients. That's how we got the 3/4 that I keep highlighting in yellow. I'm sorry. Okay, yellow, yellow, yellow. Okay. Then the radicals, we moved them in together. We simplify the fraction. Once we couldn't simplify the fraction anymore, we split them back up into their own radical sign. When we did that, we noticed we have a perfect square over here on the numerator. So that one became the 2 right here. Everything else we left the same. We would have been done over here except the rational number in the denominator. So we multiplied both numerator and denominator by the square root of 3 like we did in class several times to discover that pattern. When I do that, I have 3 in the radical, 1 out. Okay, so then the 6/4 is still there. Now we have 4 times 3 on the denominator, and then 6 times square root of 3. We multiply it across, and then our final step is to simplify the 6 over 12. Okay, and then we are done with this problem. Let's go ahead and go to number 2. Simplify the sum of 4 square roots of 27 and 6 square roots of 12. So I already know I'm adding here. Sum means plus. I'm adding these two. In class we said if they have the same root index, in this case of both square roots, and the same radicand, well, they don't. This is a 27 and this is a 12, right? However, the 27 and the 12 are large enough numbers that maybe there's still a perfect square in there that we haven't taken out. So I will go to the side and I'm going to factor both 27 and 12 so I can rewrite them and see there's a square root, a perfect square, I'm sorry, that is in there that we haven't taken out yet. It is important to know that the prime factors that I'm going to write are the ones at the end, like where it stops. 3, 3, and 3 would be for 27. So we write 4 square root of, and instead of 27, I'm going to write the prime factors. I'm going to do the same thing for 12. So the roots would be those, which are the prime factors of that. Okay, we have our coefficients anyway. And now we're going to see if there are any perfect squares or twins, like we call them in class, that we haven't taken out. And you notice that this one has a twin, right? We still have that 4 there, don't forget about it. And then 2 in, 1 out. And we're left with the square root of 3. There's no more twins. We still have a 6 here, don't forget about that one. Okay, here I see the 2 2's over here, so 2 in, 1 out, and I have the 3 left over. Okay, once I do that, I can simplify by multiplying the coefficients. So I have 12 square roots of 3 and 12 square roots of 3. Once I simplify it all the way, I notice that they're both square roots of 3. So the root index, which is a square root, and the radicand, which is 3, are both the same. So that means that I can combine them like I would like terms by adding the coefficient. So then this becomes 24 square roots of 3. And that will be the answer for number 2. For number 3, it looks like we have a distributive property situation. So we're multiplying the square root of 6 times all of this inside the parentheses. So we're going to go ahead and distribute. I'm going to write it. I have the coefficients. I'm going to highlight them in yellow as usual. So I have the 5 in yellow. And then square roots of 3 being multiplied by the square root of 6 minus the 2, the coefficient, square root of 12 times square root of 6. Remember that when you're multiplying square roots together, they're the same root index. In this case of those squares, you can move them in together in multiplication. So I have the 5 still, and now I have 3 times 6. I have the 2 still, and now I have 12 times 6. From here, I really can't tell if there are perfect squares in there that I can take out. So I can further break them down into the prime factors. Okay, so instead of writing 3 times 6, I'm going to write the 3, and then the 6, I'm going to write it as prime factorization. So 3 times 2, the product of primes. So that 6 became this. Minus 2. That 12, if you don't know the factors, you can do on the side. 4 times 3, 2 times 2. So that 12 will become 2 2 times 2 times 3. And that 6 will become 3 times 2. Now I've broken down all of them, okay? And now I can go ahead and see if there are pairs or twins, because this is a square root. So over here I notice that there are 2 3s. I still have my 5 here. I'm going to highlight it yellow again, my coefficient. Okay, 2 in, 1 out, and I'm left with the square root of 2. Okay, over here I'm going to have the minus 2. My coefficient is still there. I have these 2 in, 1 out. 2 in, 1 out. We found 2 perfect squares there to take out. And then I'm left with the square root of 2. Okay? From here, I'm going to have to multiply my coefficients. So 5 times 3 is 15. Minus, and then I'm going to multiply my coefficients. That's 4 times 3 is 12. And then square roots of 2. When I simplify them all the way, I notice that they're both square roots of 2. So I can treat them like terms, and I can add the coefficients. In this case, subtract the coefficients. So 15 minus 12 would be 3. So I have 3 square roots of 2. And that would be my answer for number 3. Okay. We're going to go ahead and go to number 4. So for number 4, we are simplifying exponents, and we don't want any negative exponents left over. Okay, so let me put my pens back to normal over here. Okay, so from here I'm going to start with each piece at a time. Okay, so I'm going to have this is one portion of it. Get my highlighter. Then I'm going to do this next portion, and then I will do this portion. Okay, when I separate them like that, I notice, hold on a second, all of this right here is to the 0 power, and I know that anything to the 0 power is 1. So even if I distribute the power of 0, it's still going to be just 1, because all of that is to the 0. So in this one I'm done, it's just the 1 there. Okay, I'm going to do the pink portion first. So I write it over here on the side. And I'll have negative 2, a squared, b to the negative second, c to the 3rd power. So that's the pink right now. Okay, first I notice that I don't have a power in the c, so I'm going to go ahead and put a 1. And I don't have a power in the negative 2, so I'm going to put a 1. That way I don't get confused when I'm distributing the powers. Okay, then after I'm going to draw my lines to each power so I don't forget that I'm multiplying. Okay, and then I'll rewrite. Okay, so now I'll have negative 2 to the 3rd power. 3 times 2 is 6. 3 times negative 2 is negative 6. 3 times 1 is 3. Okay, so that's the pink part. Done. The green part, I notice that there's no power. It's just there, so I'll just rewrite. 3a, b to the 4, c to the 5th. I'll add the powers if they're not there. So that was a green. Okay. Now I'm going to rearrange. Okay, first I notice that this is the only power that is negative, so I'm going to write it on the bottom right now. Okay, right now that I do it, because I don't like negatives. So this, I'm going to take it to the bottom, b to the 6th. Okay, so the negative is gone. Okay, now the numbers I'm going to put together. These two are regular numbers. So I'll have negative 2 to the 3rd times 3 to the 1st. Those are the numbers. There's no other ones. Okay? Then I'll go ahead and write my a's. So I have a to the 6th, a to the 1st. There's no other a's. A to the 6th, a to the 1st. I'm going to cross them out. Done with those. And then I will, this is the b's. I have b to the 4th on the top, so be careful with that. And remember that b to the negative 6, I didn't like it negative, so I put it on the bottom. So b to the 6th would be on the bottom. Okay, and then lastly, I have the c's, c to the 3rd and c to the 5th. They're both on the top of the numerator. Okay, so I have separated everything with their like terms. The numbers, let's take care of them. Negative 2 to the 3rd power. Remember, the negative 2 was inside of parentheses. So really this includes the negative as well. So 2 times 2 times 2. In other words, negative 2 times negative 2 times negative 2. So that would give me a negative 8 because I have 3 negative signs. So I would have negative 8 times, and 3 to the 1st is just 3. So all of that would give me negative 24. So I'm going to write it over here. I have negative 24, and they were all in the numerator. Okay, now I'm going to move to the a's. Okay, so they're being multiplied. So when I multiply powers with the same base, I add the exponents. So here I would have a to the 7th. If you're having issues with that, you can expand it. You can write 6 A's and then the 1 A and count them all together, and you'll notice you have 7 A's. So 8 to the 7th. I'm done with the A's. Check and check. Now the B's. Okay, I have 4 on the top and 6 on the bottom. So remember, you're canceling them out, or you're drawing, all of them together. I'll show you how it looks in expanded form in a second. So we know the shortcut is to subtract. So 4 minus 6 would give me b to the negative 2nd power. But I don't like negatives, so I'm going to already put it on the bottom. Okay? If you were to expand the b's because you forgot, like, oh, I really don't know how to do this one, I totally forgot. Take it to the side and do 1, 2, 3, 4 b's on the top. 1, 2, 3, 4, 5, 6 b's on the bottom. And then you will cancel out, and then you'll notice that yes, you do have 2 b's left on the bottom, which is b to the 2nd over there. So this is done. And now we have the c's. They're both on the top. They're being multiplied, same base, so we add the exponents. Or you can expand it as well. So we'll have 6c to the 8. Okay? And after that, we are done simplifying, so that would be your answer for number 4. Okay, we're going to move on to number 5. This one we did in one of your packets, so we're going to go ahead and redo it right now. We have this portion right here, this portion, and this portion. So I'm going to do one at a time. So this one I'll rewrite 4f due to the 3rd to the negative 2nd power. Okay, this is the yellow portion. From here, okay, I have to give the power of 1, and then I will distribute or give the power to each. So I'm multiplying each power by negative 2. So I'll end up with 4 to the negative 2, f to the negative 2, and g to the negative 6. So I'm done with the yellow part. Now I'm going to do the pink part. And it's all to the 2nd power. So I'll put a 1 for all the ones that don't have powers, and then distribute the power of 2 to all. Okay, so I'll have negative 4, this is times, negative 4 to the negative 2nd power, f to the negative 2nd, g to the negative 6. Oh, I'm sorry, this was positive. Positive 2. Sorry about that. So 4 to the 2nd power, f to the 2nd power, g to the 6th power, and h to the 2nd power. Okay? Now I'm going to do the green portion. Okay? I'm going to give the power of 1 to those that don't have a power. Okay? So now I have 3 to the negative 1, g to the negative 1, h to the negative, sorry, this was in there. The noise outside is distracting me. I apologize. Okay, So only 3 and G did not have a power, so I put a little 1. The fourth power was for the H. H to the fourth times -1 became H to the -4. Okay? Before I do anything, I think I'm going to rewrite a lot of things because I see a lot of negatives. Like all of these have negative exponents, and all of these have negative exponents. Okay? So I'm going to have to rewrite them so that they're on the bottom, and I don't have to deal with negative exponents. Okay? So I'm going to rewrite everything. These are good. They're all positive exponents. I'll just rewrite that. Okay? And then all of these I'm going to write on the bottom, so the negatives are done. So I'll write 4, and now it's gone to first squared, f squared, g to the 6th. Negatives are gone because I moved it to the bottom. 3 to the first, g to the first, and h to the 4th. Okay? Now that I'm done with the negatives in this stage, now I can start grouping things together. All the numbers, I'm going to write over here. So I have -4 squared. Remember the -4 was initially without parentheses. And then 4 squared at the bottom and 3 at the bottom. So make sure that if they're numerators, you put them as a numerator, if they're denominators as a denominator. Okay, now I'm going to do all of the f's. And I don't see any more f's. So I'll have f squared on the numerator, f squared on the denominator. I'm done with those. I'll do the g's. I have g to the 6th in the numerator, g to the 6th in the denominator, and g to the 1st in the denominator. Okay, and then I'll do the h's. I have h squared and h to the 4th. Okay, so now that I've split them all apart into their categories, now I can begin simplifying them. Okay? So over here, -4 squared is going to be 16. 4 squared at the bottom is 16, and then times 3. Okay? I don't have to multiply that and then divide. Like these 16s become a 1, and I have a 3 on the bottom. So my number becomes 1/3. The f's, I notice that they're both the same on top and bottom, like they will become 1. So f's are gone. In the g section, I notice that these two are the same, and I just have that g left at the bottom. Okay? And then the h's, I have 2 on the top and 4 on the bottom. So I'm going to subtract, because when I divide powers with the same base, I subtract the exponents. So I'll end up with h to the -2, but I don't like negatives, so I'm going to put it on the bottom. Okay, and we don't need negatives for simplification. For this portion you don't get, you expand it, h at the top, and 4 of them at the bottom. Cancel, you're left with 2 at the bottom. That's how you put h to the 2nd. And right here I will be done. I simplified it all the way. Okay? Alright. So I'm going to stop the video, and we'll have part 2 coming up.